Hello, everyone. December 4th. Alright, let's do this. Good. We can solve the other one. Partitions with even sum differences. Here are given nums length n. A partition is defined as index I. Split an array into two non-empty subarrays such that left subarray is this, right is this. Return the number of partitions where the differences between the sum of the left and the right subarray is even. Okay, so we're just gonna add up into here, and then we do this, and then we do, okay, yeah. Not prefix sum, it's just sliding. It's like prefix and suffix sum. Okay, so we say p sum, suffix sum, all right. Okay, what do we want? Number of partitions where the difference between the sum of the left and right is even. So we say for int I equal to you know what? I think this will be more generic. So I equal to nums.size minus 1. Right, and now every time I'll remove this, actually it should be this, right? So p sum will be minus equal to nums I. This sum will be plus equal to nums I. If p sum minus s sum mod 2 is equal to 0, so I don't need to go, I can just do rest plus equal to this equal to 0, and then I'll return rest, and this will stop, right? So we'll do the I equal to 1. So I remove, add, and then that's it. Looks good. Yeah. Pretty simple. Okay, we're done with this. So we're gonna go back to this one. Count trapezoid. Yeah, it's okay. Oh, wait, hold on. The trapezoid. Oh, it's a different. We didn't solve this trapezoid thing. Holy crap. Yeah. Trapezoid. We need to go trapezoid. All right, we need to go trapezoid. Oh man, trapezoid is when? Which day is trapezoid? It's 5 for 3. So yeah, this is trapezoid. Okay, output 11 should be 10. See, they all have the same. Let's say this is a hold on. This is minus 89 is here. Okay, so I have, so this is 71 minus 89 minus 75 minus 89 is 11. So we have minus 9, 11, minus 24 here, minus 24 minus 89, and then minus 51 minus 89. Hey, it was easy. Minus 77 here, minus 77 minus 89, and then we have here is 42, 11. Okay, so I'm not sure if they have more parallel. Oh, am I double counting? So this is 1. This is a 1, 2, 3, 4, 5, 6. 6 times 5 divided by 2. That's 15. Huh? 15. Oh, hold on. This one doesn't count. We don't have this one. My bad. This one doesn't count. So that's just 1, 2, 3, 4, 5. So 5 is 10. Right? So I have 10 here. So it should be 10. But it feels like this is also a thing, which means we count them twice. And is that true? The difference between these two. Wait, hold a second. You don't have this. I don't know why you keep thinking this is a real thing. This is not a real thing. This is not a real thing. But I'm pretty sure there is something, right? There is something. I don't know. Minus 9, 59. This is 42 and then 24. What's the difference between the two? 66. Do we have 66? Yes, we do. This and this is 66. Nope, not this one. My bad, this one. This and this is 66. And this is 66. Yes, so exactly. That's what we thought. Okay. This makes things a little bit more complicated. So we have duplicates, right? Oh. So what we have now is for each line segment, right? And this says slope and the lines. So for the same slope, right? For the same slope, we have line segments, we have points, right? That's what we do. Counter is giving me the points. So for the same slope, I have the points. I have the number of points. And what can happen is these points also belong to another parallel. Oh my god. Oof. How are we going to, oh man. This made me feel like this solution is not going to work. Yes, I have the parallels, but what do I do when the parallels cross? I mean, we're double counting, so if we can find the trapezoid that has both parallel, that we can just remove those, right? How do we find that? So we have all the parallel lines, right? We have all the parallel lines, which is inside here. We have the slope, right? So we have the slope, we have, you know, lines, slope. What is lines? I forgot. Lines is, yeah, lines is the DSU. So we have slope and the lines, right? Slope and the lines. So what we need is for each line, each slope, we need to cross with a different slope, right? So we basically say, oh, hold on, are you kidding me? So basically we're saying, if I have 4 slopes on one, and we have 3 slopes on the other, how many in total can we do? Well, we pick 2, that will form 1. We pick 2, that will form 1. So it's going to be, 4 times 3 divided by 2 times 3 times 2 divided by 2. So they can form 6 times 3 equals 18. So those 18 are double counted. Let's try. I think it's just a double counting issue, right? So like different slopes. So we have a little double counting issue. So all the slopes represent a slope with a pair. Find all, for each slope, what are the lines? For each line, we use union find to gather all the points on the line. Then for each slope, produce an array of parallel lines and the number of line segments on the line. Then we can compute the number of trapezoids for each. However, this will lead to double counting, right? When when a parallelogram can form from two sets of slopes. Thus, we need to do another round of computation to find the total number of parallel. I probably misspelled it. Parallelogram. 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 So right. The number of parallelograms. The answer should be the number of trapezoids. Actually, I misspelled this. Number of trapezoids computed, right? Computed using only parallel lines of the same slope minus the number of parallelograms. So here is res. So this is counting the total number of trapezoids with double counting, right? With double counting of parallelograms. Then we shall say count the remove the double counted parallelograms. How do we do that? So what we need to do is to find how many lines there are, right? How many? So we need to know total number. So we have like each slope, right? We need to get the slopes. So we can say auto slopes equal to slope lines dot get keys. I don't know how do we get the keys? C++ get map keys as vector. Transform back. Alright, that's not how I want. Yeah, let's just say vector of we need to do this. We need to transform this into, oh my goodness. So it's gonna be a pair of a pair. No, that's not what we want. We just want to count, right? So line count per slope. Okay. Then what we're gonna do is for auto lines of slope lines, we say line count per slope dot pushback lines how many lines? Dot size. That's the number of lines. Right, because lines no lines. Wait, what is lines? Lines is a DSU. Okay, yeah, that's not right. Lines is a DSU, so we need to find how many parents, right? How many unique ones? So that's actually not right. I think it's a little bit more. Oh, why don't you just do it right here, right? So count total number and then and keep track of the number of parallel lines for each slope. So we'll do this one here. Okay. We'll do this one here. So we got the lines. We got the lines per slope. And this is to get the number of points. But what I want is to know what is the total number of parents. Right, so what I can do is I'll set up an unordered set of int. So this is the unique lines, and then I mean technically I should go through parent, but it's okay. So we'll do this and then unique lines dot add lines dot find I. Okay, once we're done, we can say p equal to lines dot find I. Then here we say p, and I'll add p. Push. Teeth. All right, I'm back. Let's continue. What do we have now? We are trying to find a number of unique lines, and then we're using. Oh, it's not push. What is it? Unordered set, right? What is the API for unordered set? Unique lines dot. Huh? I don't know. Wait. Unordered set. Is that add? Insert. Jesus. So yeah, we insert. Once we're done, so we know how many. Then we say line count dot pushback unique lines dot size. Yeah, I don't care. I just create a new one. So this we got the line count per slope. Right now we need to remove the double counted. So we do this here is going to be I0 is smaller than line count dot size I plus plus for int j equal to I plus 1, j smaller than line count per slope dot size j plus plus. So what we do is res or minus equal to. So actually let's do this. So int c1 is line count does I, right? c2 is line count j, and then res or minus equal to c1 times c1 minus 1 divided by 2 multiplied by c2 times c2 minus 1 divided by 2. So this is the number of different combinations of parallel lines for the first slope multiplied by a different combination of parallel lines of the second slope, and each of the two pairs can form a parallelogram, and then these are double counted. So we remove those and then we do the return. All right, let's try this. Wow, this is truly a pretty darn. I don't think it's like difficult. It's just things that I didn't consider. What the hell happened? Oh, I should go from here. My bad. This is okay, let's see if this one make it work. Oh my goodness. It didn't work. It didn't work on all. Wait, what? What? Ah, that's ridiculous. Okay, something is not right. The unique lines I'd expect to be the line count for each. That's not right. Huh? Oh, that is not. That is not. I see what the problem. The problem is counter. Ah, yeah, blah, blah, blah. So this C has to be larger than 1. Okay, that's fine, yeah, this is not supposed to be here, it shall be here. If C is larger than 1, then we will insert That's a counter. What would be the best way to do it? We'll do it here. If counter P, right, is larger than 1, then we insert. That means that is a parallel line. Okay, so we got the others, but we got the first one wrong. What the hell? So the first one, why? Why? So this I shall have 2. So parallel lines, I have this. Right, I have this. These two are parallel lines. And then I have this. Oh, you gotta be kidding me. Oh man. Oh man. Not all parallel lines form because these are not full lines. Jeez. Ugh. They don't form. Yeah, that's actually right, because you can have, these are not parallel lines, these are this, right? They don't form. Yeah, it doesn't work. It doesn't work. Then what? How do you dedupe them? Right, so when I have bunch of segments and bunch of segments, how do I know this and this form a... I don't. So like basically we have this, right? We have this. This is the case that our thing cannot work, because we'll count this and we'll count this. It's supposed to be 1, but we count it twice. Now it's because when we are handling, like on this parallel line, we know what the points are on this parallel line, right? We know the points are on this parallel line, and we know the points on this parallel line. I have the points. Because if they belong to a parallel line, the counter P is larger than 0. So yeah, I can get the point. I can get what points are on it. That is possible. Okay? That is possible. The counter is number of points on each parallel line. Yeah, number of points. So, but I need to know the exact point. Okay, like I know the exact point is gonna be this. I know the exact point is gonna be this. And then on the other parallel line, I know the exact point. I know the exact point. So when this parallel line, so when this pair this pair and this pair gets formed, we'll see that they are the same. Oh man, this doesn't feel right. This doesn't feel right, but I still feel this is a promising, it's a promising, right? It's very promising, but it just, it just lack one thing. It just lack one thing. Or we rethink about the problem of finding parallelograms. What do you think about that? Let's just find parallelograms. That's basically what we are getting stuck with. We need to find the number of parallelograms, not trapezoids, right? We just need to find the number of parallelograms and then we do the minus, that's it. What we have now is basically, it's wrong, the way we're counting parallelograms. So we just need to find the parallelograms. Yeah, it's as simple as that, parallelograms. How do we find parallelograms? Well, what we need to find is 4 points. So we know the parallels, right? So for each one, so for each slope, we can get the points out. Okay, for each slope, we get the points out. For each slope, we get the points out. And then for 2 slope, we just see if there are 4 points. So that's not for each slope. That's the thing. It's not for each slope, right? Oh yes, for this slope, we have 1, 2, 3, 4, right? They all have this slope. And for this slope, we have 1, 2, 3, 4. So basically, just if we have slope 2 points, right? 2 points. We have another slope 2 points. All we need to do is to find how many, if we have 4 points that exist in both here and here. We just do a set union, right? We do a set union and then we have the number of points that exist in both, right? We do a set union, then it will exist in both. So now the question is, how many would that be? Because this slope must be, we have points on them, right? We have points on them and we have points on them. Then if they exist in both, then I think, so if I have 2 on one slope, okay? And these 2 also exist on the other slope. That is not possible because 2 can only exist on one slope, right? So it must be like a 3, right? So we have this, then we have another one, then it forms. So we might have 6, right? We might have 6. Oh, then you have more parallelograms. Damn, how do we count a parallelogram like that? Right, so we have this, these are parallel, and these are parallel as well. How many parallelograms are there? You're shitting me. Well, the parallelogram is the same. They are the same as trapezoids, right? So we just do the exact same thing. Like we have, but just do it on one side. Right, so we have this, so on this we have, 1, 2, 3. On this we have 1, 2, 3. Then we just do, as 3, so we have 3 times 3 equals 9. So 9 of them gets counted twice, right? Because when we do the other one, we also count from this perspective, right? We have 1, 9. There's 9. That ain't right. It has to be parallelograms. So we basically we have 6 points. Any 4, that is not right. Not any 4. It should be any 2 from the top and any 2 from the bottom. They can form parallelograms. That's the same. It's 9, right? 1, 2, 3. And then we can have, 4. Oh, wait, hold on. No, it has to be parallel. So that in this case, we also have this. Oh, dude. Lord. Oh, this is more complex than I had expected. I think I'm not using the right. Anyway, let's revert to the previous one. Yeah, I need to revert to the previous one. This is not right. Yeah, I know why this is not right, but we have to remove the parallel, like all the parallels that you can find. So given, we can find, oh, holy crap. So given 2 sets of parallels, right? We need to find, so this is a different set of parallels, okay? This is a different set of parallels. So given 2 sets of parallels, let's not get distracted by this. Given 2 sets of parallels, how many parallelograms can we find? And we know that it's good because these points exist on one and they exist on the other, which means if I know the number of lines and I know the number of lines, these all form. So any line with any other line, this I think it will work. Yes, I think this will work. Because this is only one line, and this I can do 1, 2, and 3. So in total, this will give us, this will give us 3 parallelograms. Parallelograms, right? This will give us 3 parallelograms, and those are the ones we need to remove from the result. So we just need to find for each pair of slopes how many points, and it has to be for what if I have 5 points? That's the same. 1, 2, 3, 4, 5. And then let's say these are happen to be on the parallel. No, that's not 5 because this point is not on here. So it's not possible to have 5. That's the same, right, on the 2. Right? It's not possible. But here we have actually 3, right? Because we have this, have 1, 2, 3, essentially 4, 5. This is what we have. But this and this, the same point is only 1. Like this is 4, right? So you can have 1, you can have 2. No, you cannot have 2 because this is not a pair. A pair. A pair. Now you have to find all the different pairs. All right, I need to think about this. This is a little bit more involved than I had expected. Okay, I'm gonna revert. Yeah, this is not right. But anyway, we'll leave it there.